Hi amigos, in today's video, programming paradigm. The first time I came across this word, I pronounced it as paradigm. Yes, paradigm. And for a noticeable period of time, I had been pronouncing it as such. I don't know why nobody ever corrected me though, but when I finally figured out that I was pronouncing it wrongly, I saw that fool out of me. But I think that made sense after all because it made great impression in me. Hence, I always find the whole concept sticking to my memory. Do you want me to share this interesting concept with you? Well, stick around and have it known. What is the meaning of the word paradigm or paradigm if you want? Well, it literally means a model or a pattern for something that may be copied or imitated later. Think of it as a method you use in approaching something. As usual, let me even give you a metaphor. Take the quadratic equation x squared plus 2x minus 3 equals 0. We call this equation a problem because it requires solution, right? And to solve this problem, one needs to use one of the famous methods we have for solving quadratic equation, which are the factorization method, the completing the square method, the general formula method, or you call it the quadratic formula method, or you call it the almighty formula method, or finally one needs to use the graphical method. Each of these methods embodied a different pattern of solving the problem. The way you approach to solve the problem using factorization method is different from the way you approach to solve the problem using completing the square method, and so on. So because of this, we can refer to these four methods of solving quadratic equations as the four paradigms of solving quadratic equations. Do you understand what a paradigm is? Good. Another important thing to note is that some paradigms or approaches cannot be used to solve some problems. Say for instance the equation x squared plus 7x plus 3 equals 0 cannot be solved using factorization method. You can try it and see. Don't expect me to solve any of these equations because obviously this is not a math class. They are just for example's sake. Most importantly, hope you've understood what paradigm means. Now, looking at it from a programming point of view, what is programming paradigm? It is simply an approach to solving programming problems. If you want, it is a pattern, a model, or a method for solving programming problems. There are about 700 programming languages today. You might think that theoretically the number is astronomical, but practically it is not because units or tens of programming languages can't solve the problems we have today in the world. So these hundreds of programming languages are specifically designed for use in certain applications. We have different types of programming paradigms, each consisting of many programming languages. In a hierarchical structure, let's study the common types and classifications of programming paradigms. Clearly, you can see there are two categories of programming paradigms. We have the imperative programming paradigms and the declarative programming paradigms. Imperative programming paradigms are those paradigms that mainly focus on outlining the steps in solving a problem. In this approach, a programmer instructs the computer on how to progress from one state to another until the goal or the desired state is reached. So it is more of modeling series of states from initial state to the final state that tell the computer how to solve a problem. States. What are these states? Well, they are sequence of instructions that tell computer how to move from point A to point B and so on. That is how a problem is solved in this category. The program executes from point A, which is the initial state, to point B, from point B to point C, from point C to point D, and so on to the final state, which is the solution state. Therefore, at the final state, the problem is already solved. On the other hand, declarative programming paradigms. As the name suggests, they are paradigms that declare what kind of results should be produced by a computer program. In this approach, results of execution are prioritized over states or steps of solution, simply making it the opposite of imperative paradigms, which focus more on steps of solutions. To tie up everything, with declarative paradigms you tell the computer what you want, that is the result. And with imperative paradigms you tell the computer how to get what you want, that is the steps of solution. Some of the common paradigms under imperative are procedural programming paradigm, structured programming paradigm, and object-oriented programming paradigm. In procedural paradigm, codes are written in blocks called procedures or subroutines. Each subroutine is a state, holding a set of instructions that clearly define how the computer should change the state of the program. That is, each subroutine progressively moves the state of the program towards the goal state. And since it focuses on changing the states of the program, it makes sense that it falls under the imperative parent, because changing the states of the program is the same thing as following steps of solution. Examples of programming languages that fall here are COBOL, Fortran, Pascal, C programming language, etc. As for the structured programming paradigm, it aims to improve the clarity and the execution speed of a computer program by making use of what we call control structure or control flow. Control flow simply means the order in which instructions are executed. We have the normal control flow, we have the conditional control flow, and we have the repetitive control flow. This will be discussed in detail in our future classes, so don't worry much about it. Examples of languages that fall here are Java, C#, C++, etc. C# is written as a letter C followed by hashtag. I made mention of the C programming language as of when I was given an example of the languages that fall under procedural paradigm. And just now I mentioned C# and C++. Well, note that these three languages are different. The last one we are going to look at under imperative programming paradigm is the object-oriented programming paradigm, which focuses on organizing software design around objects. Meaning objects come together and interact to solve programmable problems. You can think of objects as anything, say books, trees, humans, teachers, schools, anything. Object-oriented programming paradigm is best understood when looked at in detail. And fortunately, that's exactly what this course is designed around. In no time, we will dive into object-oriented programming in detail using Java programming language. So just hang in there and be excited. Examples of the programming languages that belong here are Java, as you could tell, C++, JavaScript, Python, etc. Now I hope it is obvious how the procedural programming paradigm, structured programming paradigm, and the object-oriented programming paradigm are centered around steps of solution. And that is exactly why they fall under the imperative programming paradigms. Under the declarative programming paradigms, we have the functional programming paradigm and the logical programming paradigm. Think of functional programming paradigms as the functions we have in mathematics. The math functions are equations that take any given numerical input from a set we call the domain and produces a unique output from a set we call the codomain. Say for instance the equation f of x equals 2x plus 1. Its result solely depends on whatever the input happens to be, and no single input can yield more than one result. That is why it is called a function. Let's try some simple inputs and see for ourselves what the corresponding outputs will be. We can see in the first instance of this equation we input 1, and f of 1 is equal to 2 times 1 plus 1, which is equal to 3. In the second instance we input 2, f of 2 equal to 2 times 2 plus 1, which is equals to 5. In the third instance we input 3, and 2 times 3 plus 1, which is equal to 7. Now it should be crystal clear that no single input can result to more than one output. There is no way we can get a number that is not 3 having inputted 1 in this function. The functional programming paradigm is identical to the math function in terms of operation. It consists of subroutines called functions that accept inputs as arguments and thereafter return the required output. So from my explanations, you should understand that the functional paradigm focuses more on the results gotten from a calculation. It doesn't really give a heck about how the calculation is done. Example of the programming languages that fall here are Python, Haskell, Clojure, Lisp, Erlang, etc. And finally, the logical programming paradigm consists of predicates and rules of inference. What are predicates? What are rules of inference? Well, predicates are statements of facts in the world we live, like saying water is a liquid. This is what every sensible person knows, and therefore it is a fact. Like saying, if X is water, then X is a liquid. So the conclusion X is a liquid entirely depends whether or not X is a water. And the fact that in this paradigm we care more about what a conclusion or a result might be based on some conditions or some premises, we say that it is valid to be a child of its declarative parent. Example of the programming languages that fall here include Prolog, Logtalk, Hilog, etc. You might have noticed that some programming languages such as Java, Python, C++, and so on fall under multiple paradigms. These languages are referred to as multi-paradigm languages. In fact, majority of the famous programming languages today are multi-paradigm. For example, despite Java being object-oriented, it still implements some features of procedural programming paradigm, structured programming paradigm, functional programming paradigm, and more. And that makes Java a prominent programming language. Before we end this video, a frequently and ridiculous asked question is that what programming paradigm is the best? Well, the most accurate answer is that there is no best paradigm. It all depends on the kind of problem you encounter at the time of choice. No single paradigm is capable of solving all the world's programmable problems. Therefore, programmers combine the models represented by these paradigms to solve complex problems. And thankfully, you are about to have Java in your toolkit. Complex problems are those problems that require the combination of multiple paradigms to be solved. In the future, you might encounter complex problems, and that might challenge you to put forward your skills and experience to bring a powerful programming language to life. If you succeed, then you might consider naming it after me. I am glad you've made it to the end of this video. See you in the very next one.